Class 7 Atomic Structure. In this video, we shall learn about the characteristics of subatomic particles. Subatomic particles. The discoveries made by different scientists prove that atoms of all elements are made up of positively charged protons, negatively charged electrons, and neutrally charged neutrons. The protons, electrons, and neutrons that form an atom are called the subatomic particles. Protons, neutrons, and electrons of all elements had the same property. Let us now know the properties of these subparticles. Properties of protons. Protons are positively charged particles found inside the nucleus of an atom. The magnitude of positive charge in an atom is equal to the magnitude of negative charge in it, and so the atom is neutrally charged. Mass of a proton is equal to 1 atomic mass unit, that is equal to 1.6 into 10 power minus 24 grams. The symbol for proton is 1H1. Let us now learn about the properties of neutrons. Neutron. Neutrons have no charge. They are found inside the nucleus of the atom. The protons and neutrons in the nucleus are together called as nucleons. Except hydrogen's protium isotope, all elements have neutrons. The mass of a neutron is equal to 1 atomic mass unit, that is equal to 1.6 into 10 power minus 24 grams. So we see that the mass of a proton is equal to the mass of a neutron. The symbol for neutron is 0n1. Let us now know the properties of electrons. The electrons are negatively charged particles moving around the nucleus in an atom. They revolve around the nucleus in specific orbits. The mass of an electron is negligible when compared with the mass of the proton or neutron. Mass of electron is equal to 9.1 into 10 power minus 28 grams. That is equal to 1 by 1837 atomic mass unit. The total negative charge of all electrons outside the nucleus is equal to the total positive charge in the nucleus. So, atoms are electrically neutral. The symbol for electron is -1e0. -1 represents the negative charge and the 0 represents the mass of the electron, which is negligible. The force of attraction between the protons and neutrons in an atom is called Yukawa Force, and it is much stronger than the force of gravity. Now that we know the properties of the protons, electrons, and neutrons, let us now know what is atomic number. Atomic number Z. Z stands for Zahl, which means number in German. The number of protons, which is equal to the number of electrons, is the atomic number of an atom. The atomic number of hydrogen is 1. That is, number of proton in the nucleus of hydrogen is equal to 1, and the number of electrons around the nucleus of hydrogen is equal to 1. Let us see some more examples. The atomic number of helium is 2. And the atomic number of oxygen is 8. That is, the number of protons equal to number of electrons in helium is equal to 2, and the number of protons equal to number of electrons in oxygen atom is equal to 8. Let us next know about atomic mass or mass number. As mass of an atom is concentrated in its nucleus, mass number or atomic mass is equal to number of protons plus number of neutrons. The atomic mass or mass number is represented by the letter A. A is equal to P plus N. That is, atomic mass is equal to number of protons plus number of neutrons. Example, lithium has 3 protons and 4 neutrons. Therefore, atomic mass or mass number of lithium is equal to 3 plus 4, that is equal to 7. We know that the mass of the atom is concentrated in its nucleus. So, the mass number or atomic mass is equal to the sum of the protons and neutrons in the nucleus of an atom. Every element is represented by its atomic number and mass number. Let us now see how the elements are represented symbolically. Symbolic representation of an element. The symbol of an element is written with its atomic number and mass number. An element is represented by its symbol with the atomic number Z indicated as subscript and the mass number A indicated as superscript. That is XAZ. Example, nitrogen 14 means atomic number of nitrogen is 7 and its atomic mass or mass number is 14. H11 means hydrogen atom with atomic mass 1 and atomic number 1. That is, hydrogen atom having 1 proton and 0 neutron and 1 electron. C12 indicates carbon atom with atomic number 6 and atomic mass 12. The atomic number 6 indicates that the number of protons and the number of electrons in carbon atom is 6. To find the number of neutrons, the mass number is subtracted by the atomic number and we get the number of neutrons. That is, 12 minus 6 gives 6 neutrons. Similarly, beryllium 94 indicates that there are 4 protons and 4 electrons, that is equal to the atomic number in the beryllium atom, and there are 5 neutrons, that is atomic mass 9 minus atomic number 4, that is equal to 5. 5 gives the number of neutron in the beryllium atom. Boron 11 indicates that there are 5 protons and 5 electrons in the atom and there are 11 minus 5, that is equal to 6 neutrons in the boron atom. Next, let us see how the electrons are arranged around the nucleus of an atom. Electronic configuration of atoms. We know that electrons in an atom go around the nucleus of the atom along orbits or shells with different energy levels. The distribution of electrons in different shells or orbits is called electronic configuration of atom. The distribution of atom in each shell is given by Bohr and Bury rule. Bohr and Bury rule. Rule 1. The maximum number of electrons in a shell is equal to 2n square, where n is the serial number of the shell from the nucleus. Example, the first shell from the nucleus, that is K shell, can hold 2 into 1 squared, that is equal to 2 electrons. The second shell or the L shell holds 2 into 2 squared, that is equal to 2 into 4, that is 8 electrons. The third shell or the M shell contains 2 into 3 square, that is 2 into 9, that is equal to 18 electrons. The fourth shell or the N shell can hold 2 into 4 squared, that is equal to 2 into 16, that is equal to 32 electrons. Rule 2. Shells with increasing order of energy get filled in a stepwise manner. That is, the K shell gets filled before L shell. Rule 3. The outermost shell cannot have more than 8 electrons, even if it has the capacity to hold more electrons. Example, Calcium has 20 electrons, which gets filled as 2882. That is, the K shell has 2 electron, L shell 8, M shell 8 and the N shell 2. Geometric representation of atomic structure of elements. Knowing the atomic number and mass number of an atom, its atomic structure can be represented pictorially. For example, O168 represents oxygen atom with atomic number 8 and atomic mass or mass number 16. We know that atomic number is equal to number of protons, which is equal to number of electrons, equal to 8. And the mass number is equal to the number of protons plus number of neutrons. So the number of neutrons is equal to mass number minus atomic number. That is equal to 16 minus 8 is equal to 8 neutrons. So number of electrons is equal to 8. Therefore, the electronic configuration is 2, 6. The atomic structure of oxygen can be pictorially represented as below. We draw the nucleus with 8 protons and 8 neutrons in the center and the K shell around it with 2 electrons and then the L shell with 6 electrons. In this way, the atomic structure of the different elements can be represented. Pictorial representation of the elements with atomic number 1 to 20 is given below. Valence shell. The outermost shell of an atom is called the valence shell. Elements which have the same number of electrons in the valence shell have similar properties. Example, lithium, sodium and potassium have one electron in the valence shell or outermost shell and they have similar chemical properties. They are called alkali metals. Atoms with different number of valence electrons show different chemical properties. Example, valence electron, that is electron occupying the valence shell of sodium is 1 and of magnesium is 2. They show different chemical properties. Elements having valence electrons of 1 or 2 or 3 are metals. Elements with 4 to 7 valence electrons are nonmetals. Let us next know about the isotopes, isobars and the isotones. Isotopes. Atoms of the same element can have different number of neutrons. Hence, their mass number will be different. Atoms of elements with same atomic number but different mass number are called isotopes. Example, the 3 isotopes of hydrogen H11 protium with 1 proton in its nucleus and 1 electron around it with no neutron in the nucleus. The second isotope of hydrogen, that is 1H2 with 1 proton and 1 neutron in the nucleus and 1 electron around it. The third isotope, that is 1H3, has 1 proton and 2 neutrons in its nucleus and 1 electron around it. We see that the number of neutrons in the nucleus of the hydrogen atom varies in the 3 different isotopes. But the number of proton is equal to the number of electron going around the nucleus. So, the atomic number is same but the atomic mass varies. Few more examples of isotopes are carbon 612 and carbon 613, chlorine 1735 and chlorine 1737, oxygen O816, O817 and O818, boron 510 and 511 are some of the isotopes. Isotopes are of 2 types. They are stable and unstable isotopes. The unstable isotopes are radioactive. That is, they give out radiations and are called radioisotopes. Example, uranium-235, UR-235-92, which is used as a source in nuclear reactor. Cobalt-60 is used in radiotherapy. Next, let us see about the isobars. We saw that isotopes have same atomic number but different atomic mass or mass number. Now we will learn about the isobars which have same mass number but different atomic number. Isobars. Atoms that have same mass number but different atomic number are called isobars. Example, calcium with atomic number 20 and mass number 40 and argon with atomic number 18 and mass number 40 are called as isobars because even though their atomic number is different 20 and 18, their mass number is the same 40. What is an isotone? Isotones. Atoms of different elements with different atomic number and different mass number, but the same number of neutrons are present in them. These are known as isotones. Example, boron 11.5 and carbon 12.6. The number of neutron in boron 11.5 is 11 minus 5, that is equal to 6. And the number of neutron in carbon 12.6 is 12 minus 6, that is equal to 6. So we see that the same number of neutrons are present in boron and carbon atom. Since both boron and carbon have same number of neutrons, they are called as isotones. Hope you are clear about the properties of the subatomic particles, the atomic number, mass number, and the different isotopes, isobars, and isotones. Let us meet in our next video. Thank you for watching. Please like, share, subscribe, and click the bell icon.